So to solve for the inequality for y, we're going to subtract the 8x on both sides. So that's going to give me y is less than negative 8x plus 6. That's all you have to do. They're not asking you to graph the first or the second. So all you have to do is solve it. Now for the next one, I will go ahead and subtract the 3x on both sides. So it's going to give me 2y is greater than negative 3x plus 10. I will divide by negative 2 everything, and that's going to give me that y is less than 3 over 2x minus 5. Remember, when you divide or multiply by a negative, it flips the sign over. Now for the third one, they want us to graph it. So again, we're going to have to solve for it first. So I'm going to get minus 4x on both sides. And it's going to give me 3y is greater than negative 4x plus 9. I'll divide everything by 3. And I end up with the equation y is greater than negative 4 over 3x plus 3. So then I will start by graphing the y-intercept right here at 3. Then I'll go down 4 and then 3 to the right. Down 4 and 3 to the right. Or up 4 and 3 to the left. Either way is fine. And now we're going to figure out whether it's going to be a dotted or a solid line. And it's going to be a dotted line because it's greater than. There's no or equal to at the bottom. Now afterwards, I'm going to check. They're saying that y is greater than. So we want to shade up from our y-intercept. And this is where we shade, in this area right here. Now that we did the warm-up, we're going to start with 6.6, which is system of linear inequalities. So after today, you guys should be able to graph and solve system of linear inequalities with 2 variables. So the vocabulary we're going to use is system of linear inequalities. You guys are used to it with system of linear equations. That's when you had 2 equations and you solve for the x and the y using either substitution, elimination, or graphing. Now the solution of a system of linear inequalities is an ordered pair. In this case, for the inequality, for the equation is an ordered pair, but for the inequality is the shaded area that they're going to match. So we have a system of linear inequalities. It's a set of 2 or more linear inequalities containing 1 or more variable. And the solution of system of linear inequalities are all the ordered pairs that satisfy the linear inequalities in the system. So you guys are used to seeing linear equations. Remember when you did linear equations, you had the graph, and you had 2 lines, and your solution was that point that they touched. Now, if we have system of linear inequalities, let's say it looks like this. You're going to have, let's say, the dotted one you shade up, right? And for the other one, we shade this way too. Notice how they collide right here, how they share that same shaded area. I changed the color to yellow. That will be the solution of the system of inequalities. So somewhere that it's true for both equations. Oh wait, sorry, they also share this part. I forgot to shade the other side. So this entire thing would be the solution for those 2 inequalities. One being an or equal to, and one being without the or equal to. Being dotted, whole line, the boundary doesn't matter, but the answer would be the place that they share. So for this one, we gotta tell whether the ordered pair is a solution for the given system. So usually in the last section, we only gave you 1 inequality and then 1 ordered pair that you plugged in. So the same thing, your x, your y, and you would plug them in, your y here and your x here. So in this case, if you guys remember, for the system of inequalities, it had to be true for both in order for it to be a solution. It's the same thing for the inequalities. I'm going to plug in the points. They already had the points written down here for us, and the equations written out for us. So I'm not going to rewrite it. I'm just going to go from there. So for the y's, I'm going to plug in the negative 3. And for the x, I'm going to plug in the negative 2. I'm going to do one equation at a time. So it's going to be negative 3 is less than or equal to negative 3 times negative 1 plus 1. Negative 3 is less than or equal to 3 plus 1. So we have negative 3 is less than or equal to 4. Now, it's true for this equation, so we're almost halfway there. Or we're halfway there. Now, we got to do the same thing for the second equation in order for it to realize whether it's true or not. So we're going to do -3 is less than 2 times -1 plus 2. So we get -3 is less than -2 plus 2. We get -3 is less than 0. Now, -3 is less than 0, so we know it's true. Therefore, this is a solution. Now remember, key part, it has to be true for both inequalities. If it's not true for both inequalities, it is not a solution. So it has to be true for both inequalities for it to be a solution. If it's just not true for one of them, you can stop. It's not a solution. It has to be true for both. Just like the equations we did before. So let's go ahead and work on this. We're going to plug in the 5 for the y and the -1 for the x for both equations. I'm going to start with the left one. So it's going to be 5 is less than -2 times -1 minus 1. We get 5 is less than 2 minus 1. 5 is less than 1. Now, clearly this is not true, so this is not a solution. Now, if you stopped right here, if you did the left one first, you can stop and say, hey, I'm done, this is not a solution. Just for the fun of it, let's do the right side just in case you did the right one first. We get y, it's greater than or equal to -1 plus 3, so 5 is greater than or equal to 2. So if you did the right one first, you notice it is going to work for the right equation. The y is greater than or equal to x plus 3. And that way you would have to keep going into the second. So the second, you'll find out it's not a solution. So overall, -1, 5 is not a solution for this system of inequalities. Remember, an ordered pair must be a solution for all inequalities to be a solution of the system. This is just a reminder of what I said before. For it to be a solution, it has to be true for both. And then if it's not true for one, it's not a solution. So as long as one of the equations or one of the inequalities, which is what we're going over, is wrong, like it's not a true statement, it's not a solution. You don't have to keep going. All right, to show all the solutions of a system of inequalities, linear inequalities, we gotta graph the solutions for each inequality individually, and then the solutions of the systems are represented by the overlapping shaded region. So below are graphs of examples 1a and 1b on your textbook page 435, which is Salva's. Now example 1a has 2 lines. This is kind of the gist of what I did earlier with the highlighter. Notice how for the dotted line, sorry, I'm trying to get my Apple Pencil to start. Notice how we have this dotted line right here, right? And the solutions for the dotted line are this side right here. And for the solid line, which is this one, we have the shaded area right here. But for both, you see how the blue and that orangey red that they have for the example is this one right here?
Where's the trash can?
So the answer is going to be this shaded area. So any point that this shaded for both, which in this case is this area right here. Let me choose a different color. This area I'm shading in green. Any point on that shaded area is going to be a solution for that inequality, for that pair of inequalities. If we look at example 1b, we have the same thing. We have shading right here for the red inequality, and we have shading right here for the green inequality. But they overlap just in this triangle area, so any point in that triangular yellow area would be the answer. So if you notice for 1a, they give us the example 2, 1. Since it's overlapping both regions, it's a solution. And notice how in 1b, they give us a point 2, 0, and it's only overlapping one of the 2 shaded areas. Is not a solution for the inequality. So just to reiterate, any point on this yellow marking is a solution. Anything outside of this yellow is not. Same for this. If it's not on the green right here in this green area, is not a solution. if it's in the green area, is a solution. So we want to graph the system of linear inequalities and give two ordered pairs that are solutions and two that are not solutions. So let's graph this one we'll do this one in black, and we'll do this one in blue. Yeah. So looking at y is less than 3, when y is 3, it's going to be up here. And it's going to be a solid line because we have that or equal to. So I'm going to go ahead and draw the straight line, the straight solid line, or as straight as I can get it. And since the inequality is telling me y is less than, the y becomes smaller as we move down. So I'm going to shade everything in the bottom of that line. And then for the other equation, we're going to start at positive 5 because that is our y-intercept. And we're going to go, we have a slope of -1, so we're going to have a slope that looks like this. Again, this is just a bunch of little points that I'm doing to make it a little bit easier to draw the line. Now, this is going to be dotted because it does not have the equal sign. So I'm just going to try my best to dot this line. Again, notability might be a little easier. So we have this dotted line. They're telling us, though, that y is going to be greater, right? So y becomes bigger for that equation. We go up, so that's the area that we're going to shade. So we're going to shade everything up here and everything up from that line. Now, in notability, the lines are going to overlap better when it comes to the colors. So I'm just going to change the color here. Notice how this section right here, I'm going to keep using yellow for right now, is the area that they overlap, right? Now, if you do it in notability, you'll see the colors overlapping, which is a lot easier. Here, the colors kind of don't mesh together, but it's okay. That's why I'm changing it. So they want us to give two ordered pairs that are solutions and two that are not solutions. So the two ordered pairs that are solutions are going to be any points that are in that yellow area. So I'm going to just choose, let's say, 8, 0, and I'm going to choose 10, 2. Those two are solutions, they're in the yellow. And then you can choose any points for the not solutions. For the not solutions, for the no solutions, you can even choose any point in here, any point in here, or any point in here. Yeah, as long as it's not in the yellow area, you guys will be fine. So I'm going to just choose a point right here. That is -5, 5. And I'm just going to choose another point in the black area, -2, 0, right here. Because even though it's true for one equation, it's not true for both, so it's not a solution to the given inequality system. So to start this problem, they want us to graph the system of linear inequalities and to give two ordered pairs that are solutions and two that are not solutions. So in order to start this first equation, we're going to have to rewrite it into slope-intercept form. So I'm going to go ahead and start by adding the 3x on both sides. I want to add the 3x. I have 2y is greater than or equal to 3x plus 2. I will divide everything by 2, and I get y is greater than or equal to 3 over 2x plus 1. I'm going to graph that one in black since this is the color I'm already using. So I'm going to start at 1. I'm going to go up 3 and 2 to the right. Again, I'm just going to plot a few points so it's easier for me to kind of graph this. Okay, so this is going to be a solid line because we have the or equal to at the bottom. I'm going to go ahead and draw that in. Now, that is telling us that y is greater than, so I'm going to go up from that y equals to the y-intercept, and it covers everything on this area. Now, I'm going to do the other one in blue, just like the other problem. I'm going to start graphing it at plus 3. And then I have a slope of 4. So I go up 4 and 1 to the right, up 4 and 1 to the right, or down 4 and 1 to the left, down 4 and 1 to the left. When I do that, I realize is a dotted line because it doesn't have the or equal to, so I'm going to dot this line or dash it. And we have left this line. Now they're telling us that y is less than, so from our y-intercept, we're going to draw it down from our line. So it's going to cover all of this area. And if you notice, they overlap right here. Again, I'm going to do it in yellow. Not the eraser. Oops. This is the area they overlap. So again, I'm going to do it in yellow just to emphasize the color. That's where they overlap. Now, the ones that are solutions, again, are the ones inside. So I'm going to pick this point right here, which is 2, 6. Another solution I'm going to pick is right here, which is 4, 10. One that are not solutions, so I'm going to put it as NS. I'm going to choose one in the black, so right here, -6, 1. That's not a solution. And another one that's not a solution, I'm just going to put this. It's 9, 0. So neither of those are solutions, and the two that are solutions are in blue. All right, so I'm going to go ahead and graph this first line in black like we've been doing, and the second one in blue. So graphing this first line, we're going to start at the y-intercept equaling to 1. And then we're going to have a slope of 1 to 1. So it's going to be all of these points. Again, I'm just drawing them to make it a little easier to draw. Now, this is going to be a solid straight line because we have that or equal to. It's going to look kind of like this. So it's going to give us telling us y is less than. So we're going to draw down from that line. So all of this. And then we're going to do the other line in blue. That's going to be y is equal to 2. So we're going to draw that dot right there. That's a horizontal line, and it's dotted because we don't have the or equal to at the bottom. So you're going to do the line right there. And they're telling us that y is greater than 2, so we shade up. All of the y is greater than 2 is going to be that. So we're going to overlap right here. So we have the black and blue area in the right side. I'm going to change it to yellow so you guys see it. Now you don't have to change it. It's just so you guys can see it better right now. Again, they want 2 points that are solutions, since 2 that are not solutions. So we have solutions S. I'm going to pick these 2 points. That is 0.6, 4 and 8, 5. And then not solutions are, again, points anywhere else on the graph. I'm going to pick a point right here and a point right here. That is point -9, -4 and -7, 0. Now, you will have homework tonight. It's going to be posted in a few minutes. You can. It'll be open before 11. But yeah, that's it for today's notes.